Next talk, it's my great pleasure to welcome Professor Joseph Stiglitz, winner of the 2001 Nobel Memorial Prize in Economics, to give this lecture at our classes in Berlin.
Well, thank you, and it's a pleasure to be here again. What I'm going to do this morning is, first I'm going to rehearse some of the well-known failures of traditional economics, macroeconomics, in the context of the crisis. I expect this is a more receptive audience to those criticisms than some of the other audiences I've been in. But this is partly done to set up the discussion where I'm going to focus on two specific attempts to create alternative models. And I'll spend most of my time talking about one. I may not have time to go to the other, where I'll explore one particular question, which is, does more interconnectedness lead to more or less economic stability? And this is an issue that I know so many of you are working on, and essentially was ignored from much of the standard macroeconomic framework. So to begin with the maybe by now well-rehearsed failures of modern macroeconomics, it's very clear that it didn't predict the crisis. And if you say we're talking about prediction, if you say what is a good science, it's prediction, and if you can't predict the most important event in 75 years, what good are you? And in particular, it might be very nice that you can talk about the likelihood of a 1/10 increase in GDP growth rate. You know, all the discussions, growth may be 2.1 or 2.0, and you can talk about that with some precision, but you miss a major economic downturn. It's worse than that. They said those kinds of things couldn't happen. So it wasn't just that they didn't forecast it. The theory said the events that happen couldn't happen within the context of the model. It's important to try to understand, though, more deeply what went wrong with these models. Many of you have the advantage that you never had to study them closely. And I don't want to encourage you to do that. But for those of you who at one time or another had to study macroeconomics and have had that inflicted on you, I want to go through quickly what I see as some of the major failings of those frameworks. They were based on very strong economic assumptions, but also very strong mathematical assumptions that were often hidden. The economic assumption that has gotten a lot of attention is that there were rational individuals with rational expectations. And what that exactly means is a more complicated question, but what is clear that the behavior that was observed is hard to reconcile with any common notion of rational behavior with rational expectations. The standard model also typically used or derived from versions that used what was called a representative agent model. And that assumed that there was one person in the economy. Now, it's very difficult to model an economy when everybody's identical. In particular, you lose out on a lot of things. It's hard to have a lender because with only one person, the person is lending to himself. And so you don't have very interesting financial markets. The issue of bankruptcy and default doesn't become very important, because if you go into default, you just owe money from your left pocket to the right pocket. Not a big deal. And for me, one of the really worst consequences of the representative agent model is it's very difficult to have information asymmetries. As you know, I spent a lot of time talking about information asymmetries that one person knows something that others don't. And the only way in these models that you can get information asymmetry is to have some version of acute schizophrenia. And that interferes with the other assumption of rationality. So there's a tension, and it's virtually impossible to have any interesting model with information asymmetries. And if you think information asymmetries are key to understanding financial markets, and it's really hard to talk about any interesting financial markets with perfect information, you really have to say that those models, which were the core of macroeconomics, were non-starter. It was amazing that anybody paid any attention to them. But some people, including in some central banks, did. One other assumption is that most of the models that were taught in graduate schools assumed that the key shocks to the economy were exogenous. It was something like, they called them technology shocks, weather, things like that. But we all know that the shock that happened to the economy in this crisis was not related to weather or to technology. It was a credit bubble. And we've had those credit bubbles since the beginning of capitalism. So what's remarkable is the intellectual bubble that led people to believe that there were no such thing as credit bubbles when there had been 200 years of history of that. And that's something of intellectual history that we ought to try to study. How could people be shall I say, stupid? So the basic point is that the assumptions and the conclusions were inconsistent both with historical experience and a big wealth of micro evidence. Now that wouldn't be so bad if it was just graduate students who had to suffer from having studied these models. The problem was that some policymakers, including many people in central banks, studied these models and took them seriously. And then goes, from Ben Bernanke, Alan Greenspan on down. So that led to this view, some elements of which are still prevalent, that keeping inflation low was necessary and almost sufficient for stability and growth. Government didn't have instruments to prevent bubbles. It was cheaper to clean up the mess after the bubble broke. Most of these doctrines that were at the center of central bank policy have now been widely discredited, at least in some quarters. And interesting, I was at we held a meeting at the IMF about a year ago. A book has come out called In the Wake of the Crisis, Lessons from the Financial Crisis, where even the IMF has now rejected most of these doctrines about inflation targeting. It hasn't rejected them as strongly as I would have liked, but it has much more qualified in their perspectives. One of the, again, interesting aspects of the crisis is not only did the models not predict the crisis, even after the bubble broke, they made wrong forecasts about where the economy was going to go. There's a famous statement that Bernanke, one of the problems when you're a central bank governor is everything you say gets recorded. What I say nobody pays any attention to, but when you're a central bank governor, everything you say gets recorded and repeated later. So it's striking that they are not more careful than they are. But one of the things he said, and you understood why he said it, he says, don't worry about the bubble and housing broken. The risks have been contained. They hadn't used a sophisticated model as we just saw here, but they believed the risks were contained. Well, obviously, they were wrong. The question, though, is how could they be so wrong? And part of the reason, and you see this very deeply, they were using models that told them the risks were contained. And the essential ingredient in that model was risk diversification. And it was really the central idea that had underlay a lot of the research over the preceding 15, 20 years. So you created a model with a lot of concavity, risk aversion, and in those models, if you divide risk, you spread risk out over the world, the risk gets smaller and smaller to the point it's no longer a risk. So the theory was that with well-functioning financial markets, spreading risk, diversifying risk, risk is contained. And so they came to believe the models, and that's always dangerous. So they came to believe that was the great virtue of the financial innovations, and that they had spread the risk all over the world, and therefore there was no risk. And no significant systemic risk. There was no systemic risk. Well, as I say, it's obviously wrong. We have to ask, where did they go wrong? It's also clear that the responses to the crises, based largely on the advice from economists, have also clearly been inadequate. Still the case, say in the United States, that almost 1 out of 6 Americans who would like a full-time job can't get one. It's clear that the labor market's not working. Demand for labor is not equal to supply of labor. But most of those models assume that labor markets work very well. They have no explanation for why things have gone so badly. If I were in the context of a political speech, Romney versus Obama, I would explain what the mistakes were and how the policies of the Republicans have made things even worse. But this is not a political analysis, so I'm going to skip over that, and maybe if we have time in the questions, I'll be able to come back to those obviously very relevant policy issues. But from the analytic point of view, from the model point of view, to me, one of the most striking aspects of what was wrong with the models was the models didn't focus on credit. They had variables like money supply, but the notion of credit was not there. The interest rate that they focused on was the T-bill rate. And the mechanism by which the economy was largely affected by monetary policy was through the interest rate. Well, one of the things that many of you may have discovered is that you can't borrow at the T-bill rate. The T-bill rate, the real rate of interest right now is, in the United States, the T-bill rate, the real rate, T-bill rate is negative. And most of us can't borrow at that rate. I wish we could, because if we could, we would be very wealthy, because we could then invest it at assets with even moderate positive real rates of interest and become wealthy, like the banks have been doing. So the ECB lends at a negative real interest rates and allows them to put their money in a positive real interest rates, and it's a massive gift to the banks and the Federal Reserve. It's a standard procedure giving away money to the banking system in a non-transparent way. Well, but what was striking is that they didn't have these models where you analyze the spread between the lending rate, the T-bill rate, what was going on in the credit system. They didn't. Many central banks didn't even have models in which there were banks. The financial system was modeled as a demand and supply for money. I don't want to oversimplify, but the standard macro model, that was the core of the model, was a demand and supply for money, and not for credit. Well, the point is that in the crisis, banks as institutions turned out to be important, and the behavior, the bankruptcy of banks played a very important role in the economic crisis. Of course, given that they didn't have any good models of banks, it's not a surprise that Bernanke didn't know what to do when the banking system collapsed to get the banking system going back to work. So the fact that they hadn't modeled the credit system which I view as central to understanding how the financial system was a very important gap, lacuna in the literature. The other part of what had transformed in the United States and Western Europe was there was a move towards securitization to capital markets, and that was applauded very widely. But again, they didn't understand the inherent limits of securitization. And those inherent limits have a lot to do with information itself. And they go back, the problems of the securitization go back to a couple of very simple ideas of paper that I wrote with Sandy Grossman, where we show the impossibility of informationally efficient markets, and the notion that once you have a capital market, a securitization market, information becomes a public good. When a private bank lends money for a mortgage, if the mortgage goes bad, it bears the consequence. So it's a private risk. Once you go to securitized, then whether that particular mortgage goes bad is of concern to every one of the people who bought that security. But there are millions of those, or at least thousands, and that means that information has been made a public good. And what do we know about public good? There'll be an undersupply of public goods. And so you'll have an undersupply of the information activities, selecting and monitoring. So securitization has a fundamental flaw associated with it. Now, we thought there was an answer. And that answer was the credit rating agencies would supply that public good. But credit rating agencies are not agencies. They're private, for-profit, maximizing firms in a non-competitive industry where there was incentives. They were paid by those they were rating, and it was a race to the bottom to provide the worst information. And they were fantastically good at providing distorted information. What was so amazing is, and that is inconsistent with irrationality, a lot of people believe the rating agencies. Of course, the rating agencies were saying, don't worry, we've monitored our conflict of interest, and people thought maybe we had a legal system that would hold them accountable, but it's been very hard to hold them accountable. There's just one suit going on right now in the States to trying to hold them accountable. And their performance was, quite frankly, dreadful. So the point is that securitization didn't work, information deteriorated, and the mortgage market didn't function. Now, I mention this in part because Bernanke and the Fed didn't understand this. They thought after the crisis they could recreate the securitization market. Remember, you probably don't remember these new programs we had. One was called TALF, which was intended to recreate the securitization market, and it failed. And the reason is that the market had figured out that there were some problems. They didn't figure out exactly what the problems were, but they figured out something was wrong. And for those of you who haven't followed it, it still isn't working. The US government is underwriting about 90% or more of all mortgages. So we do not have a capital market for mortgages working in the United States. And no one has figured out how to go back to a private market. And there is no theory about why this huge market should be in the public sector. And neither on the left or the right is there a view that it should be in the public sector. But the argument is we can't figure out how to make the private sector work. Well, this is a little bit an aside, just an emphasis that what you hear from people like Trichet and others, the real problem is flexible labor markets is really nonsense. The U.S. has the most flexible labor market, not done very well. Countries with more rigid labor markets have done much better. But one of the things I do want to emphasize that illustrates the inconsistency between standard macro and what's been happening is standard economic theory says, okay, there's a misallocation of resources before the crisis. The private sector misallocated lots of money. A greater waste of money, by the way, than any government has ever done in peacetime and democracies. So when anybody talks about inefficiency of government, just say U.S. private financial markets, and that's an answer to government inefficiency. Massive scale. The calculations people are doing now about what the consequences, the full consequences, in trillions of dollars. Well, but still, having wasted all this money, misallocated resources, misallocated capital, mispriced, the question is, once you discover the mistake, the conventional competitive equilibrium model says you're supposed to go back to full employment. And there have been cases where you have this V-shaped recovery. But this one is not a V-shaped recovery. It's a long U-shape, or there's a lot of bumps along the bottom. There has not been recovery. And there is no good standard economic theory that explains why it should take so long. Even if people are indebted, the standard competitive equilibrium theory says that there are a set of wages and prices at which markets clear. They're different from what they would be if people weren't in debt. But the standard equilibrium theory is that whatever your inherited past, there is an equilibrium at which markets clear. So something is not working about the markets that is leading them not to clear. I mean, when I say not clear, the most important is the labor market, where the demand for labor is not equal to the supply of labor. There's unemployment. So something is not working. Well, what I'm going to try to do is to talk a little bit about a couple of the reasons for this. And the two, the one I'm going to, the two, as I say, I'm going to talk about is some of the aspects of the instabilities associated with interdependencies, interconnectivity, and the consequences of a major structural transformation. So let me begin with the question, does interconnectivity lead to more or less systemic risk? As I say, to think about this, you have to have economic models in which you have more than one person. You have to have economic models in which you have lots of countries, lots of banks, whatever. And I'm going to talk about this in a fairly abstract way where the units can be countries or the units can be banks. It doesn't make a lot of difference. In practice, as you model it more finely, there are differences, but I'm doing the analysis at a fairly abstract level. So the notion is that the failure in one financial institution led to failures in others to the point where the system was at risk. And that was the kind of analysis that we just heard. What are the institutions that are really systemically significant? Their failure will lead to others. And the same thing, problems in one country in the United States led to problems in others. And this is a phenomena that economists have called contagion. As I said, the standard answer that has underlaid discussions in economics now for many a year is that the spreading of risk with concavity leads to better outcomes, the risk diversification. But there is an underlying assumption here, and that's a mathematical assumption, and that's the assumption of concavity. You all know if there's convexities in the system, spreading of risk can lead to amplification. So this is an example where thinking about other sciences, where in economics the notions of concavity are so embedded that diminishing returns, you go back to Ricardo, they're so embedded. And if you go back to Samuelson's foundations, he just assumed they're everywhere. So it's been so, economists have been so brainwashed that they don't even take it as an assumption. But the fact is that as soon as you start talking about bankruptcy, learning, information, you start seeing that their non-convexities are pervasive in our economy. And that means this notion of diversification may not work. And so I'm going to try to give some simple models that will illustrate that in a hopefully forceful way. And in that context, interlinked systems are more prone to system-wide failures with huge costs. And in some ways, this crisis illustrates the risk. There's one economic insight here that is absolutely essential, particularly important for understanding banks, but it's pervasive, and that is that the privately profitable transactions may not be socially desirable. The basic idea of Adam Smith was that individuals in the pursuit of their self-interest would lead to socially desirable outcome. We would say now Pareto efficiency, Adam Smith's invisible hand. And those of you who know the work I did with Bruce Greenwald know the basic, our result, our 86th theorem, I sometimes summarize as saying the big insight was the reason that invisible hand often seems invisible is because it's not there. And we proved that generically, markets are not constrained in Pareto optimal. When I say constrained, taking into account the cost of information, the information asymmetries, the cost of creating markets. And the corollary of that is that there are many contracts that people are privately profitable transaction contracts, deals, credit default swaps, that might be privately profitable but be systemically bad. And that means there is a need for government intervention. So it's moving from the premise that underlies a lot of financial economics that the reason people create markets like credit default swaps is they're completing the market and making the market more efficient. And therefore, the system will behave better if we have all these additional markets. And what we are showing is that's not true. You're creating these additional markets, but there are externalities when you do that, and the system as a whole may behave worse. Trying to explicate that to try to understand the circumstances in which that's true is obviously very difficult and is part of our research program I'm doing with Stefano here. But there are some important results that have come out, for instance, the work of one of my students, Anton Kornek, which is looks at the privately profitable level of indebtedness, or the privately profitable level of indebtedness in foreign denominated indebtedness, dollar denominated for an emerging market. That optimal degree of indebtedness for the private party is systemically inefficient. There's over-indebtedness. Because there's an externality which you can trace out and see how the system behaves worse because of this. So that's an illustration of the Greenwald-Stiglitz theorem that privately profitable contracts may make the economic system perform more poorly. And once you recognize that, there's a need for government intervention. And the problem is to try to identify important examples of this, important phenomena where we can do that. Well, before going into a little bit more details in the model, I want to emphasize the deep intellectual incoherence of much of standard macroeconomics, particularly in the context of the IMF and the international. Because what do you hear all the time? They tell countries you ought to open up your capital markets. Why? Because you can diversify risk. But after a crisis, what is the word that they use all the time? When a crisis strikes, they say we have to intervene in Greece or in Thailand or Korea. Why? What's the argument for intervening? Contagion. But contagion, mathematically, is very different from risk diversification. They don't have models that coherently integrate the risk ex ante, the benefits ex ante, and the cost ex post. And if you're designing a system, you want to ask the system, what's the structure of the system that's optimal for reducing the risk of a crisis, but also reducing the consequences of a crisis when it occurs. And if one interdependence is bad and the other way is good, you have to balance the two out. And in none of their analysis do they do that. In fact, if we go back to the word contagion, and this conference is partly about metaphors or analogies drawn from other disciplines, the word contagion, of course, comes from epidemiology, disease contagion. And you ask the simple question, if somebody has a disease, do we approach the problem of disease control by diversification? We say, oh, we have a group of people who have a disease, let's spread them all around the world and diversify our risk. Well, obviously the answer is no. And so obviously the mathematics of diversification do not apply to disease. And if you look at the mathematics that we usually use in describing the transmission of disease, it's a multiplicative process. A very strong non-concavity. And you can formalize this in this context. So that just illustrates this. There's another example that actually has already been referred to, and that is electricity networks. We know that there are advantages of integrating electricity networks. Because if you have isolated electricity networks, you have fluctuations in demand. If you want to have a 1% probability of overload, of a brownout, you have to have a certain amount of excess capacity. If there is imperfect correlation between the demands in two different communities, if you join those two communities together, the total capacity that you need is reduced because one of them can fill in for the deficiency in the other. So there are big benefits in capacity utilization of capacity, construction of capacity by constructing an integrated network. But what's one of the problems of constructing an integrated network? Well, we saw that in the United States. I don't know if you have had similar problems here. But we have occasionally brownouts or blackouts. Some people like blackouts. They give you a moment disconnection from your, all kinds of things go on. But the fact is that the system is not supposed to behave that way. So the point is that when you have a more integrated, the probability of a system-wide failure goes up. If you have two different regions, two different parts, you're not going to have a universal system blackout. You'll have one or the other, but not both. But the probability of both is very, very low. So the probability of a system failure goes up if you interconnect. But there's a benefit and that's a benefit cost. People in design electric networks worry about this. And how do they control the problem? They're aware of it, and they control it. And they control it at least partially by creating circuit breakers. But for economists, the analogous thing to a circuit breaker has been an anathema until about a year and a half ago. What is the analogous thing to a circuit breaker in economics? Capital controls. The movement of capital, you have an integrated financial system, you have a problem, and you take that country and you say, you can't move money out of that country or into that country. You isolate it. You put it into quarantine. Going back to the metaphor of medicine. So both in medicine and in electrical networks, we respond to crises by quarantine in one way or another. And there is an economic analogy, which is capital control, but the IMF and the conventional wisdom were very strongly against that until a year and a half ago. And now they're beginning to talk about it as maybe appropriate in certain circumstances. One of the theoretical issues is, how do you design these well? You know, electrical engineers work very hard to design good circuit breakers. Since we weren't allowed even to think about it, we haven't begun that question, but that is part of the question we are proposing. Well, I'm running out of time. I'm supposed to stop when?
About 7 minutes.
7 minutes. So you'll have to read the paper to get all the squiggles. But the basic idea is to have a model where you have a random variable, say a stock, which you can share with others. You have sharing rules. And the question is, what is the nature of the community in which you're really engaged in risk sharing? That's a simple model of interconnectivity. And so it's basically some a very simple model where the non-convexity is introduced by way of a bankruptcy cost. So if your stock goes below a certain level, you go into bankruptcy. And then you look at the probability with different risk-sharing rules that various units go into default. And the consequence, and then the question is, what is you can calculate the probability that under different organizational architectures, I call architecture, different way of setting up the system, the risk-sharing contracts, the probability 1, 2, n firms go into bankrupt, and therefore you can calculate the expected value of the loss of the system. So you can estimate the systemic performance, which is basically here the payments that you have to pay in bankruptcy costs that are going to be affected by these risk-sharing mechanisms. And there are just a few results. Let me summarize. The first is that liberalization, under a set of assumptions, full integration, let me put it like this, full integration of all the countries, of all the financial markets, never pays. It's always better to have some isolation, because as you get full integration, the risk of systemic breakdown goes up. There isn't, in this model, an optimal size club. A club is where you have a group of countries sharing risk. That restrictions in capital flows are desirable. One of the interesting is in analyzing the systemic performance, one of the interesting trade-offs, and I think it was manifested in the crisis, is that some architectures, as I call them, some arrangements, are good for sharing small losses. You have small losses, they can provide a buffer, but very bad for big losses. So you have a trade-off between the performance if you have a small loss and performance that you have a large loss. The word that's sometimes used for these large losses are resilience. And these have to do with the notions of fat tails. You know, things that, so if you're in a normal probability distribution, the system can look like it's very good. But when you get a big shock, it collapses. And this is sort of illustrated. I don't know if this diagram will be clear, but what this is a model where it shows that you have sharing for N1 is a low level of sharing, N2 is a high level of sharing, and what you get is the low level of sharing, better performance, lower losses. But when you have a big shock, the higher level of sharing has a bigger loss. And that's like the system collapses. So that's an important aspect that I think can be modeled a lot better. There's another aspect that we haven't talked as much about, and that is that the importance of uncertainty about the institutional arrangements themselves. And this goes a lot to the non-transparency of the banking system. If you have risk sharing, but you don't know who is sharing the risk, then you have a shock, you don't know who it is that's going to be affected. So that systems of broader risk sharing without transparency can actually become more fragile. Because you get an amplification of the amplification effect from the uncertainty. So just a couple observations. The impact of shocks depends on the size of shocks, the correlation among the shocks, how the shocks are distributed, the architecture of the network. One of the things that's happened is that banking systems have evolved into a few concentrated nodes. Some of the diagrams that you saw in the first session sort of illustrated that. And these kinds of big nodes, there's a typo there, are interlinked. And this system seems to be good for absorbing small shocks, but it can be very bad for absorbing big shocks. For the obvious reason, these big things can absorb little buffers, but if the shock gets big enough that it trips the big guy, the whole system collapses. And so when we were thinking about this, there's a natural evolution because people are always thinking about the ordinary shocks and not the tail effects. So this is an evolution of structure that you could understand given the limited understanding of risk. And let me, as a side point and a diatribe about my acquaintance with the guys who are running some of our largest banks, they wouldn't know a probability distribution if they saw one. So the fact that they didn't understand fat tails is not a surprise. They didn't understand thin tails either. So they're trying to manage risk without knowing probability theory. And they can't even talk because they were trained as lawyers. They know litigation risk. That's the only kind of risk that they understand well. Well, there's a whole set of problems. What I just described is fairly mechanical, but economics tries to always embed these things in incentives. And behavior doesn't just happen mechanically. There are people have reasons for behaving a certain way. And one argument we have is that government bailouts, socializing losses, when you have too big to fail banks, actually leads to too big to fail banks. And you can see that in the data, the too big to fail banks can get capital at a lower interest rate than smaller banks. Why? Because the government is implicitly guaranteed. Not for certain, but the market makes a judgment that they are likely to be bailed out and they can get capital at a lower rate. That means they grow relative to others, not because they're more efficient, but because of the hidden subsidy. Well, as I were in a little bit of a political diatribe, not only do they have too much economic power, they have too much political power, and they're too big to be held accountable. Oh, but let me give you 3 more minutes.
Yes, that's fine.
Okay. I think that indicates that I'm almost out of my time. Okay. But there's not only a problem of too big to fail, there's a problem of too interdependent to fail. If they start making links with each other, then they can't fail. But they have an incentive to become too interdependent because that is like insurance. So they know then that the likelihood that they will be bailed out goes up. And then finally, there's a problem of too correlated to fail. That even if they are small, if they're all doing the same thing, they all get in trouble at the same time, they all get rescued at the same time. Interesting policy questions of how do you prevent too correlated to fail. I have a prescription, but you can't, I'm told I can't talk about it. There are also other perverse incentives because by increasing complexity, especially with interconnectedness, you create information asymmetries. And one way you make, we teach this in the business school, competitive markets are your enemy. Your job, if you're going to make money for your shareholders, is to make the market non-competitive and to get rents. Of course, we don't need this is terrible for economic efficiency, but the bankers understand that. And they work to create non-transparent market and try to make sure the regulators don't force them to be transparent. And so we can explain how complexity and opaqueness in contracts lead to information asymmetries and increased profitability. Well, there are some other elements in systemic risk. One of these is well known, which is called bankruptcy cascades. Although bankruptcy of one firm leads to a bankruptcy of another, that has to do with the design of the architecture of the financial system. A really important thing that I'd like to, it should be an important area of research. The other one is trend reinforcement. It's another example of a non-convexity. When a firm starts to go down, say it has a negative shock, describe the firm as a stochastic process. It gets a negative shock. This is worth the stuff on it. It goes down. If there's a higher probability of default, the interest rate that it borrows at goes up. What that means, the probability of going down next period is even greater. So there's a trend reinforcement. You get a negative shock, you're more likely to go negative. So that means increasing non-convexity, and that means that more likely to hit the boundary value of bankruptcy. Well, if you have this non-convexity, going back to the general theorem, diversification may not pay. And so there's an optimal degree. What we show is there's an optimal degree of diversification. Let me just mention one aspect of the, one part of the other topic I was going to talk about, and that's the structural transformation of the economy. One of the reasons, most of the models in standard macroeconomics have fixed parameters, you have stochastic shocks, and you evolve an economy over time. What we're suggesting is there are episodic big changes in the structure, like phase changes in the economy. These are big changes, and markets don't handle these big changes well. And the big changes, of course, are changes like from agriculture to industry, our industry to the service sector. These big changes are, in some sense, a result of our success. We had high increases in productivity that meant we didn't need workers in farming. We had high productivity increases in manufacturing, which means we need fewer workers in manufacturing. But when you have these big shocks, these transformations, markets don't handle well. And moving so from one phase to another, from one state to another, is not well described by the standard macroeconomic models. And we present some models trying to describe that. But those are particularly relevant to the current economic situation. But the kinds of models that have traditionally been used, which don't recognize these structural transformations, are, I think, of very limited help. So let me conclude. The old paradigm was wrong, and policies based on it contributed to the financial crisis and to the inadequate recovery. Diversification as a practice may make an economy more unstable. The financial architecture, the design of the financial system matters for bankruptcy cascades, for how the interlink makes a very big difference for financial stability. An economic downturn related to a structural transformation, which I think the current one is different from the normal economic fluctuations and models looking at historical periods where those normal economic fluctuations are going to be of only limited relevance. From the point of view of modeling, strong assumptions lead to strong conclusions. Mathematical assumptions like convexity matter, and networks and frictions matter. Frictions are what we describe as playing a key role in the structural transformation. The old analysis was intellectually incoherent, focusing on benefits of interdependency at times, on the cost of contagion of others. What I try to do here is to outline a set of models that provide a coherent and in some sense a better description of what happened, and hopefully will provide a basis of policies that are more likely to lead to better economic performance going forward. Thank you.
Thank you very much, Professor Stiglitz, for your very inspiring talk. So I know that we can now start a very long discussion about all of these, but this discussion starts exactly in 20 minutes, so there is a coffee break right now. We can skip all your questions and save them for the second part of the panel discussion. There are two announcements. After you got your coffee, please move to the other rooms where the posters are. We cannot accommodate 200 people just in the foyer. Spread out over the whole floor, and there is also a poster session. And the second part, we still are not registered for the conference dinner tonight, so there is a chance to have